our video, we have discussed that graph box analysis. It analyzed that this blue part means that, let's see it closer, okay? The blue part means that 75% of the monthly sales revenue consists of this the sites, okay? And it is between 73% and $73,000 and $82,000, okay? And the median value here is $77,000. Okay, we can analyze it, the data with a graph box command, okay? Let's go on. After the graph box, we have the Swilk test. Okay, Swilk test, one of the amazing tests. It also, here, we can check it. Okay, Swilk test, and it would better if we write it with as docs. Okay, we should get this information in the doc format. Okay, as docs. Here, this Swilk test gives us the probability of whether the test is correct or not. Okay, here we can check Shapiro-Wilk test. Okay, we should copy it and paste in our observation paper. Okay, here I should clean it. Okay. We also use the Shapiro-Wilk test to ensure that data is normally distributed. The given data is normally distributed. We check this style, histogram style. The next style of the checking the data distribution is the Shapiro-Wilk test. Okay, if the p-value is greater than 0.05, that means data is normally distributed. If the p-value is higher than 0.05, which means that the data is not normally distributed. And here we can see that our data here is normally is not normally distributed because the p-value here is more than 0.05. Okay, in the sales, but in the advertising, the p-value is 0.03, which means that the data in the advertising is normally distributed. Okay, one of the most important part of our analysis, okay, it is finally that regression. Regression, I write it with a stock here. Okay, why do we need the regression? Regression gives us to analyze the most part of the information. For example, here we can see the here in the regression there are three parts. Okay, the first part, the second part, and the third part. I can't remember that all names very well. Okay, but we can get the information here. Okay, and here we are. The linear regression, we should copy this regression again and paste it in our site. Here I have pasted it already. Okay, and here we can get the monthly sales revenue with a estimated regression model. We can choose that we can create the estimated regression model with the help of the regression command. Okay, the table provided below indicates the most important information about the research. The regression analysis has being used to estimate the model of the monthly sales revenue. The main purpose of this analysis is to explain the relationship between dependent and independent variables. Okay, the main purpose of here. What is the main purpose? The main purpose of this analysis is to explain the relationship between dependent and the independent variable. How the variables are interconnected to each other. That means that has a relationship. Okay. Let's analyze it. Is it that? Okay, here we can conclude that if we increase that if you want to increase the sales to $1,000, we should increase that spending expenditure on advertisement to $1,700. After that, we can get increase that sales revenue, monthly sales revenue, to 1 units. Okay, with the help of that regression model, we can analyze it and we can interpret the data here. Okay, the advertising here it's written that and constant is the 70.18. Okay, here is a monthly sales revenue that model, regression model. Okay, with the help of this regression, we can analyze it. And after that, we have another comment, one of the amazing comment. Okay, A hit and Y hit. Okay, we can get this A hit and Y hit here. Okay, here. The first of all, we should write predict a hit. Sorry. And after that, I should give this comment. Okay. If you write the second comment the first, you cannot get the information. Okay. Here, the residuals. Okay. In this histogram, we check the normality test for residuals. Okay, as the residuals are the normally distributed or not. Okay. And another one, it's a hit test that whether the residuals is normally distributed, I mean the given data is normally distributed or not. Another comment is Y hat. Okay, Y hat. I don't want to give this comment the same thing, but it will give to ensure the histogram normality test, which is visual form. We test the skewness test for normality. Okay, that after that skewness test normality, the probability of the residuals should be more than 0.05. In our data, it's that 0.33 about, and it means residuals are normally distributed. Residuals are normally distributed. Here, what's going on here? This one, I mean the hats one. Okay. Here it is. If I'm not mistaken, this one. No, it's not this one. It's another one. Let's write this comment here first. I have already finished this Y hat and Y hat. Okay, here is a scatter graph, two-way scatter plot. Okay, we should write two graph-way scatter plot. Oh my god, they asked us Y hat, about Y hat. Should we? Okay, something is going wrong with this Y hat predict. Okay, after that, let's get the result here. Okay, we have copied it, and we should paste it in our result. Here I have pasted it, and that's a skewness test for checking the normality is provided, and it's considered that statistically. Here it's statistical. Form of the normality test. The linear prediction Y hat is not normally distributed as the probability is less than 0.05. Okay, understandable, yep. And next and the last one is a hats test. Okay. Hats test is which is Bruce-Pagan-Cook-Weber test. Okay, constant variance and the fitted value of the cells. We will check whether that value are fitted or not. Okay, if the here it is the same thing. Okay, that as given table provides the information that the data is not normally distributed since the probability is less than 0.05. If probability is more than 0.05, the data is normally distributed, and as you see, the probability here that's more than 0.05, which means that data is normally distributed. Let's go on. Because of the lack of time, we can get this point. Okay, graph here. Sorry, not why I had here. I should write it sales. Okay, here we can get the sales data and we should put it here. Okay, what this graph speaks about, we found that there is not a good relationship between the residual and the linear prediction. There is a good relationship between residuals, but between not linear predictions, and that's why we can conclude that that there is no good linear that relationship between the residuals and the linear prediction. Okay. And in the conclusion, we can write that taking everything into account, analyzing all data, I can conclude that there is not strong relationship between monthly sales revenue and the expenditure on advertising. Okay, that's the second. That's the last part of the first part video.